Hello, everyone. My name is Sirisha Paturi, and I'm in Juniper's product line management team. So, today I'm going to talk to you about Juniper's vision for open networking and the key areas we're investing in to drive towards that vision. The slide here shows a typical data center deployment. We have two data center networks that are interconnected through a WAN core network. Within the data center, we have the core, leaf, spine, and edge layers. Sonic has typically been relegated to the core and the leaf layers in the network. What we are doing is we are bringing in Sonic to every layer in the network so that customers can benefit from open networking end to end. In other words, we are making Sonic ubiquitous. In order to drive towards this vision, we are investing in three main areas. The first one is systems and silicon. The use cases that we are targeting, the DC spine, the edge, and the WAN core, typically require high-performance, multi-PFE modular systems. Juniper has a history of building such systems with custom silicon. By enabling Sonic on such systems, we are bringing in all the advantages and expertise to the open community. The second area of focus is Sonic and Psi. In order to support the new use cases, Sonic needs to support new features as well as high performance and scale. We are not only making these changes, but we are also upstreaming them so that the broader community can benefit from it. Examples of features that we are enabling include MaxX and MPLS. The third key area of focus for us is the routing stack. For the new use cases, you would need a feature-rich routing stack that is capable of scaling and performing in the toughest of scenarios. Juniper has packaged its industry-proven routing stack as a container. We call it the containerized RPD or the CRPD, and we are integrating it with Sonic. This way, customers can not only get advanced features like BGP and policy-based routing, telemetry, automation, etc., but they could also leverage the operational excellence that is inbuilt into Junos while reducing the complexity in a multi-vendor environment. Now let's now look at each of these areas in a little bit more detail. Juniper has started shipping 400 gig systems. The PTX 10008 is a high-density, high-performance, space-optimized 13 RU form factor. It supports the 14.40 400 gig optimized line card as well as a 4.8 tera 100 gig optimized line card. Both these line cards are multi-rate. When I say multi-rate, I mean you could enable both 100 gig and 400 gig on the same port. The system has very low power consumption. 0.1 watt per gigabit is typical. An interesting feature of the system is MaxX is inbuilt into it. The PFEs that are used in the system have MaxX integrated. So what this does is, even if you don't have a requirement for MaxX today, you just buy the system and the line cards associated with it. And if there is a requirement for MaxX in the future, you just have to turn it on. This is unlike other competitive options in the market where you would need to buy a new SKU or a new line card to enable MaxX. The system has deep buffers and it offers 50% higher packet performance with respect to other vendors in the market. Now, the use cases that we are targeting with this device is usually at the forefront of security attacks. We support filters at scale on the PTX 10008. What this means is even the most complex security threats can be mitigated using very simple, easy to construct filtering terms, and they are installed in a memory optimized manner in the chipset so that you could really scale to meet the security threats of your network. The system can also provide very granular visibility since the chipset has a capable of supporting up to 8 million counters. Now, this is the right system for the new use cases that we are targeting, namely the DC spine, the edge, and the WAN core. And this is the system we have chosen to enable SONiC on. You can reap all the traditional chassis benefits with our SONiC implementation on this chassis. The chassis will be managed as a single device with a single SONiC instance. You can take advantage of the high-performance cell-based switch fabric, and all of the components in the system are hot swappable and field replaceable. Moving on, one of the key requirements, one of the key software features that we are enabling is MaxX Support. After Snowden, customers are increasingly wanting to enable encryption technologies on links that they don't have control over. Typical use cases include enabling encryption on interpod connectivity links as well as while interconnecting data centers. The PTX 10008, as I mentioned earlier, has MaxX inbuilt into it. We support line rate 100 GB and 400 GB MaxX with AES 256-bit encryption. The MaxX SI proposal in SONiC is mainly focused on data plane. We still need MKA for control plane and XPN to support 100 GB and 400 GB MaxX. Juniper is the first to integrate MKA and XPN with SONiC. The next key feature that is typically required for DC edge and core use cases is MPLS. SONiC doesn't have support for ISIS and OSPF, so you would need an external controller to act as a label source. Juniper is the first to integrate controller-based MPLS with SONiC. The slide shows the components that you would require to enable MPLS. Of course, we have the PTX 10008 systems in the DC edge and the core roles. For the controller, you could either use Juniper Northstar or any third-party controller. When it comes to the routing stack, you need a routing stack that is able to understand labeled swap, push, and pop operations, as well as a routing stack that can integrate with controller agents. Juniper's CRPD has very well-defined JET API to integrate with controller agents. It supports ingress, egress, LER, and transit LSR functions. In the future, CRPD will also be enhanced to support features like segment routing. Finally, telemetry is important for all use cases, especially in today's environment. Juniper supports all sonic native sensors. Juniper can stream both control and data plane telemetry data through standardized interfaces, for example, gRPC. From a telemetry and visualization apps perspective, you can either choose Juniper Contrail HealthBot or any third-party open source app like Grafana or Fluentd. Going forward, we also plan to support auto-remediation and situational awareness on our products. To summarize, Juniper has all the components to enable open networking for our customers. If you start at the bottom, at the Tor layer, we have the Juniper QFX 5200, which is a 3.2 tera 100 gig system. At the leaf layer, we are shipping Sonic on the Juniper QFX 5210, which is a 6.4T 100 gig system. For the spine, edge, and WAN core use cases, we have the Juniper PTX 10008, which has both 100 gig and 400 gig optimized line cards. So 14.4T is the throughput you get per slot for 400 gig optimized deployments, and 4.8 tera is for 100 gig optimized deployments. From a routing stack perspective, you can choose to enable any of the devices shown here with Juniper CRPD. And if you would like to enable advanced features like MPLS, you would need a controller, which could be either the Juniper Northstar or any third-party controllers. For additional information, please visit the Sonic GitHub. You can also visit Juniper booth to learn more about the capabilities that we have discussed in this session. We also have a disaggregation channel on YouTube, and we also have an engineering workshop that will be conducted by Lester Bird, a distinguished engineer from Juniper Networks. Thank you.